A and AS level mathematics. Lesson 23, which is our first visit to calculus. Introduction to differentiation. On this we're going to be looking at the gradient of a curve, the introduction of dy dx, the gradient of a tangent, the gradient of any point on the graph of y equals x squared, and the tangent to a point on any curve, and we call that differentiation. So let's start with reminding ourselves of the gradient on a straight line. Now the gradient on a straight line is the increase in y over the increase in x. So we need our straight line. The other thing we need to be sure of is the scale, because the scale can make a difference. So in this case let's go 1, 2, 3, and we'll keep the same scale in the other direction. 1, 2, 3. So the scale's the same in both directions. To find the gradient on a straight line, we can pick any 2 points. We could pick these 2 points, or these 2 points, or these 2 points to work out the gradient. The gradient in this case would be 1, 2, 3, 4, the increase in y, over 1, 2, the increase in x. And whichever 2 points you pick will cancel down to the gradient of this line. That's because the gradient on a straight line is constant. The gradient on a straight line is constant. Now let's look at the gradient on a curve. Now if we pick these 2 points here, the gradient would be the increase in y of the increase in x of that line. If we pick the gradient from here to here, the gradient would be an increase in y of the increase in x. In other words, the gradient is different wherever we pick to find the gradient. So the gradient is not constant. So in fact what we have to do to find the gradient on a curve is to pick our point and actually to find the gradient of the tangent to that point on that graph. So if we wanted the gradient at the point where x equals 2, we'd have to draw ourselves a tangent, a straight line just touching the graph at the point where we want the gradient, and then find the gradient of that line. Now we could pick any 2 points. Watch out for the scale though, this scale is different. This scale is going 2, 4 over 1. So the gradient is the increase in y over the increase in x. So that would be the gradient of the tangent to the graph at the point x equals 2. So when we find the gradient on a curve, we talk about finding the gradient at the tangent at the point. And the gradient is different wherever you pick the point. The gradient is not constant. Now let's have a look how we write the gradient to the curve. The gradient of the straight line is the increase in y over the increase in x. That's the gradient of the straight line. In other words, the gradient of the tangent. But we write this in a special way. Originally written as delta y over delta x. But then after a mathematical process, which I'll come back to, it's written as dy dx. So dy dx is the way we write the gradient of the tangent to the curve at a particular point. Dy dx is the gradient on the curve. Let's look at a particular case. Let's find the gradient to the graph of y equals x squared at the point x equals 3. So there's x equals 3. We're hoping to find the gradient of the graph at that point. To find the gradient of the graph at that point, we'll need to draw a tangent to the graph at that point. And if we do that, our answer is only going to be as accurate as our diagram and our interpretation of the diagram. So we need a better way of calculating the gradient of the graph at the point x equals 3. And we're going to do this by following a set of approximations. We're going to take another point just a little bit further along the curve, say at the point 3.1. Now if I actually did that point, the diagram would be so small you wouldn't see it. So let's forget the scale now for a moment, and let's assume that that is the point x equals 3, and this is the point x equals 3.1, just a little bit further along the graph. And I'm going to find the gradient of this line, which is actually a chord. So I want to find the gradient of the graph y equals x squared at the point, let's call it P, where x equals 3, and I've moved a little bit further along the graph to a point called Q, which has an x coordinate of 3.1. If I find the gradient of this chord, it will be something like the gradient of the tangent I'm looking for. Now to find the gradient of the chord PQ, which is a straight line, I need to find increase in y and put it over the increase in x. So I need to know the x and y coordinate of both these points. Now if the equation is y equals x squared, if I substitute the x coordinate into here, I'll find the y coordinate. So in other words, the coordinate of P is going to be 3 squared, which is 9. The coordinate of Q is going to be 3.1 squared. And 3.1 squared is 9.61. So therefore the gradient of the chord, let's just write grad of PQ, is going to be the increase in y, which is the y coordinate of Q minus the y coordinate of P, over the increase in x, which is the x coordinate of Q minus the x coordinate of y. And if we work this out, it comes to 6.1. So the gradient of the chord PQ is 6.1. The gradient of the tangent to the graph at the point P is not quite as steep. So it's going to be less than 6.1. Now if I actually move the point Q nearer to P, let's say I move it to there, let's call that the point R, then the gradient of this chord will be even a better approximation to P. So let's write down the coordinates of R. Let's make R a lot nearer and make it with an x coordinate of 3.01. Therefore, if the x coordinate is 3.01, the y coordinate is 3.01 squared, which is 9.060. So the gradient of the chord PR will be the difference in the y, which is going to be 9.0601 minus 9 over the increase in the gradient of x, which is 3.01 minus 3. And if you work this out, you'll get the answer of 6.01. So if we do this a series of time, each time we find the gradient of the chord, let's say we find a point there and find the gradient of that chord, a point there and find the gradient of that chord, a point there and find the gradient of that chord, each time the gradient of the chord is going to get nearer and nearer to the gradient of the tangent that we're looking for. So let's suppose we do that. The gradient of our first chord we worked out as that. The gradient of our second chord we worked out as that. And if we now make the x coordinate very, very nearly 3,